Hello everybody, in this lecture we will be solving 2012 AIME II problem number 14. Here is a view of this problem. We have a group of 9 people and each person in this group is to shake hands with exactly 2 other people. And we would like to count how many handshakes will happen. So let's first start with one person. Well, can one person shake? Would this condition be satisfied? Obviously not. How about if there is 2 people, say A and B? A shake hands with B. Obviously shaking hands is mutual, two-sided. If A shakes hand with B, B shakes hand with A. Oh, this is like a riddle, but that's it. So A is not shaking hands with other. It's A supposed to shake hands with 2 people. He's only shaking hands with 1. The same thing with B. That case also won't work. How about n is equal to 3? Obviously, in our case, n is equal to 9. But I'm trying to have a sense of what's going on. So we have 3 people. We can arrange them like in a circular way. So can this happen now? Well, it would. A would shake hands with B and C, and B is gonna he already shook hands with A, so therefore it has to shake hands with C as well. As C, wow, so that works actually, and there's only one way this can happen. So let's take the count here. The count here was 0, n is equal to 1, n is equal to 2, 0. When n is equal to 3, the count is 1. What happens if n is equal to 4? Now I'm more and more proficient, so I can just consider a circle with 4 vertices. So how many different ways this handshake can occur? Well, the handshake can occur like so. This guy is gonna shake hands with this guy and this guy. This guy is already shook hands with one person, so he needs to shake hands with one more person. If I label them 1, 2, 3, 4, can number 2 shake hands with number 3? No, because if 2 shake hands with number 3 directly, then 4 would have to, because they already completed the cycle. 1, 2, 3 is in a cycle in a sense. They can't shake hands with anybody else, but 4 needs to shake hands with 2 other people, so that's not gonna work. So therefore we need to make sure to shake hands with 4. Come on. Okay, my pencil messed up. Okay, so 4 shake hands with 2 shakes hands with 4, and finally there is no other option, and 4 is gonna shake hands with 3. So having learned this logic, so there are some other ways we can do this handshaking business. Obviously, again, 1, 2, 3, 4, 1, 2, 3, 4. One, instead of shaking with 2 and 3, can shake with 2 and 4. Then 4 cannot shook hands with 2 because then we have a cycle and 3 is by himself. So 4 has to shake hands with 3 and 2 with 3 as well. Finally, 1, 2, 3, 4, 1, 2, 3, 4. 1 can shake hands with 3 and 4, and in that case 3 and 4 both have to shake hands with 2. So in that case the count is 3. Finally, let's play this game one more time. Okay, so this one actually will give us what's going on in the general case. N is equal to 5. Okay, so how does this handshake business happen? So 1, 2, 3, 4, 5. Okay, so so we have the vertices 1, 2 representing different people here, 4 and 5. The handshake can occur, well, 1, 2, 3, they cannot make a cycle because then 4 and 5 will be by themselves, and obviously when you have 2 people you cannot get anything going. And if 1, 2, 3, 4 become a cycle, again the same story, we will have 1 person left and that won't work. So all 5 should create a cycle. How do you create a cycle? Well, we can make a star, or let's first draw the polygon. We can make a cycle like this. That's a legit way. So that would be 1. So there must be other ways. So let's draw our thing again. And then 1, 2, 3, 4, 5. And then another way would be obviously the full thing. So I don't know if you guys remember it. So we can skip 2 by 2. So 3, 5, 2, 4, and 1 back again. And that's legit. By the way, from each vertex, as you can see, we will have 2 edges coming out of it, right? So 2 edges. That's why we need to complete the full, we need to go back to the starting point, right? Because otherwise, if you start at one vertex and you end up at another vertex, then you have an even number, for 2 of the vertices, you have an even number of edges coming out of that, which is not gonna work, because we need 2, everybody shaking hands with 2 other people. Okay, and by the way, both of these counts so far up to rotation, there's only 1 for each one. So there's only 1 for each case. Now let's be a little bit smarter. So we have again our pentagon, I guess. And now, what other way can we shake hands? 1, 2, 3, 4, 5. So we can shake hands the following way. So one would shake hands with 2, and instead of, so one is shaking hands with 2, but instead of shaking hands with, well, why not? Okay, so let's shake hands with 5, and then 5 would, instead of shaking hands with 4 like in the first case, we can shake hands with 3, 3 would shake hands with 4, and 4 would shake hands with 2. That's legit. But then this shape is not symmetric like the first situation, or rotationally at least. This one is not, so I can rotate it 4 different ways as well. So in total there are 5 of these shapes, right? Each time we rotate it. So you I guess you get the idea. It's in the spirit of Burnside, I guess, right? So that's why it's in that playlist. Okay, and finally you can have the following situation going. So we have again the vertices 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So one would, instead of shaking hands with its 2 neighbors, you would go out of your comfort zone and you would reach out to the other side of the table and you shake hands with the other 2 people opposite you, and then they shake hands with also their neighbors, and then 2 and 5 will shake hands. And again, you can rotate this 5 times as well. So in this particular case, we have 1 plus 1 plus 5 plus 5, a total count of 12. Now this is a perfect opportune moment to understand the basic logic, what's going on, right? So what has happened here? Is there an easy way to get that count? And well, yes, there is an easy way. What you can think of is that we can get all the permutations, which in this case would be 5 factorial. So how can I describe, for instance, the doesn't matter, the coloring, so the numbering of the verses. For instance, the very first guy. How can I describe this? Well, one way to describe it would be 1, 2, 3, 4, 5. Another way to describe it is 2, 3, 4, 5, 1. Another way would be 3, 4, 5, 2. So what I'm saying is we have 5 different starting points, so I need to divide by 5. But then, once you choose which vertex do you want to start from, you have 2 options. You can either make a left turn or a right turn, right? So you can, so one way to describe it is 2, 3, 4, 5, 1. But another way to describe it is 2, 1, 5, 4, 3. So that's why I need to further divide by 2. So therefore, so we get the idea. So this is 120 over 10. Haha. Okay, we nailed it. So for instance, if n, we have a cycle with 6 people, right? Right, so and if n is equal, so we can definitely generalize this. So therefore the generalization will be the following, right? So if you have n people making a cycle, so that's critical, making a cycle, so they are shaking hands on a cycle, then in that case the count would be n factorial over 2n. Aha. So now that we have our thing, our count. Let's continue. N is equal to 6. Oh, come on. Okay, n is equal to 6. Okay, so, alright, so if n is equal to 6, we need to be extremely careful. So 6 people, how can they shake hands? Alright, so think about it for a minute. So you have 6 people, how can they shake hands? Yes, they can shake hands in 2 different ways. Either they continue to do this this polygon. I think this is called a stellated polygon. Either you can create a stellated polygon where you shake hands with the 6 people, right? So something like that. I don't know. I'm just making this up. Okay, there you go. Or it's even better. So that we have 2 types here basically. Or you can have the following. You can have 2 coalitions. So you guys have these 3 people shaking hands among themselves, and these 3 people shaking hands amongst themselves. So how many ways can I count each one of them, right? So we know how many different ways to count this one. We just learned it. So 6 factorial over 2 times 6. And then you would think of this as 2 different 3 by 3 thing, and each one has 1 way to do it, right? Or 1 way. So therefore now we get the main idea. So now let's go back to our problem and let's finish this monster. So we have 9 people. Okay, so that makes sense. So n is equal to 9. So how can I split this 9? So we can have a 9 cycle, a 1 cycle of length 9, or we can have, remember, each cycle should have length at least 3. So we're talking about partitioning this 9 into different ways, right? So that's one way. An alternative way is I can partition it into a 6-3 double cycle, right? Cycle. Or I can do a 5-4 cycle. Or finally I can do a 3-3-3 cycle. Is there any other way? No. Okay, so how many of each count? Once I know the number of each count, because I already have my general formula for under each situation, right? So let's start with the 3-3-3 cycle. So how many different ways can I partition 9 people into 3 groups of 3? So that would be in 9 choose 3 ways. I can put them into the first group, but then 6 people remaining, 6 choose 3, and finally 3 choose 3. However, the name of the group's not important, so 3 factorial, right? So okay, so and then each one contributes how much? Each one contributes n is equal to 3 is just 1. Haha. Or you can just plug it in here. So does that formula work for? Yeah, it does. Okay, good. For 3 it works also. So 1 times 1 times 1. Haha. So I now nailed it, right? So that's pretty good. So how about this one? 9 choose 5, and the remaining people will go into 4. This is not symmetric, like this is 3. I don't have to divide by 2 factorial or something like that. Don't do anything crazy here. And 5, so how many different ways can we do the 5? I think we counted it already. It was 12. Okay, so this guy is 12 times 12, and the 4, we also counted that one, which was 3. Aha, so now we are pretty efficient. And now this guy here, so 9 choose 6 and 3 choose 3. Oh, this one I should have said 4 choose 4 as well, doesn't matter. Okay, and then 6 was 6 factorial. Well, I was lazy on this one. So 6 factorial over 6 is just 120 divided by 2, 60, I guess. 60 times 3 was just 1 way, and we calculate this one. Finally, the 9 cycle, just 9 choose 9 times our formula, 9 factorial 2 times 9, and that is it. So now the rest is just adding up all these numbers, and I'll leave it to you as an exercise to calculate all these numbers. In fact, when you add them, I guess you should get 30,016. Hope the calculation is correct, and as a result the final answer would be just 016, and we're done.